It's a great question. In the United States, at least, buildings consume about 70% of the energy and are responsible for about 40% of the greenhouse gas emissions. Now, that's lower on a global basis, as you might imagine. But in certain cities, like New York City, 80% of the greenhouse gas emissions are associated with buildings. And yet, when you look at that energy consumption, there's probably on average a 40% opportunity for improving energy efficiency. And then if you're thinking about water, it's been estimated that as much as 50% of the water coming into these commercial buildings is wasted. So it's fast growing. It's a huge contributor to greenhouse gas emissions and global warming, and there's plenty of room for efficiency gains. Well, obviously, it's going to help us save cost, right? It'll save costs for the building owners, for the tenants of those buildings, whether, again, you're talking commercial or residential. It will certainly have a significant impact on the greenhouse gas emissions, but also in the face of this urbanization, you consider a city like New York, where I'm based. The mayor here, Mayor Bloomberg, has put forward this plan called Plan YC, which is designed to help accommodate 3 million additional inhabitants in New York City by 2030. So it's not just a cost. My point is not just a cost issue, but he's looking at how do you absorb that many more people without any additional energy infrastructure, water infrastructure. And in fact, the objective of the Plan YC is to reduce greenhouse gas emissions by 20% relative to 2005 levels. So you have this massive infusion of folks, no greater physical, power or utility infrastructure, and a desire to reduce greenhouse gas emissions. So buildings are going to be key to allowing us to achieve those goals. So part of it is the design and placement, everything from siting to the architecture and design of the building and the passive systems within those buildings. Where we think there's a great deal of potential benefit, though, is in the active energy management of these systems. It's overlaying the physical infrastructure with a digital infrastructure. So taking building management systems, which have today historically been very stovepiped. So the security system doesn't talk to the lighting system or the air conditioning system. So the building knows when employees check in and where they're going to be positioned, but it doesn't communicate with the lighting systems, right? Wouldn't it be great if, as an employee checks into the building, it notifies the lighting and air handling systems so that they can turn the lights on and the air on in that part of the building. And similarly, when the employee leaves the building, it can, if he or she forgets to turn off their lights or forgets to turn down the air, the building can do that for them. So part of what we're trying to do here is to integrate these traditionally stovepiped, highly fragmented building systems together. The other thing that we're trying to do, and this is the announcement we made last week with Johnson Controls, because they're very good at working with these SCADA systems and the intelligent building management systems and bringing those together. What we bring to the table is the business systems. So beginning to treat your physical building assets like an asset and integrate asset management like our Maximo offerings with Johnson Controls building management systems like their Metasys offerings, so that then in an integrated way we can not only monitor the buildings but the health of those buildings and know when and have a better sense of when a pump might fail or when there's an issue with an air handler, so that we can alert the building owners or supervisors to fix those. What you'll see, first of all, is more integration across these different systems in the dashboarding of this, so that you can then have a building owner operator who might have a portfolio of buildings spread across the city, being able to manage those properties remotely and identify where events are occurring, whether it be a thermal event or an energy spike, being able to immediately see that, and then if not correct it remotely, then talk immediately to the local building superintendent to understand what's happening and to fix the problem before they get the bill at the end of the month. I think the other thing you'll see is with the advent of and progression of nanotechnology, you'll begin to see sensors becoming ever smaller, and ultimately, we envision this idea of sensor dust that will be embedded in paint, and you'll be able to have much more fine-grained thermal sensors, lighting sensors to give you more control over the buildings. The other thing I think that's very exciting is the idea of addressing the air component. So we talked about energy, we talked about water. There are places like green spaces in India where they're now growing their own air within these within their buildings, taking harmful chemicals out of the air, but oxygenating the air to improve the efficiency and the health and the satisfaction of their employees or their tenants. In fact, they claim that if you are resident in that building for an 8-hour shift, at the end of the 8 hours, your oxygen blood level is going to be 1 to 2% higher than someone who's just the average person on the street. So that's pretty exciting stuff. And it just sort of shows that we spend our lives in buildings, right? Most of us born in buildings, live in buildings, we eat, play, work, sleep, ultimately perhaps die in buildings. They're an important cornerstone of our life and of this infrastructure that we're trying to build across the planet. There's huge opportunity to improve the efficiency of buildings, to make them more livable, and we're starting to do that today.